Hello everyone, welcome to the R Masterclass lecture. In this lecture, we are going to look at how you could plot data visualization for the maps. So basically, data sometimes contains geographical location, such as for data set. If you take data set for COVID, it contains data of, for example, it would contain data of the geographical location coordinates, and if you want to plot it, it would make bigger sense if you plot on the map, because if you plot on histogram you could get and identify the trend, but if you directly plot on the map you could see the trends directly onto the map and you could visualize it way better. So basically, uh, data often tied to a geographical location. For example, if you want to have some data regarding traffic, it would contain some geographical location. Similarly, for COVID or life expectancy by a country, these would generally would contain data that is often tied to a geographical location. For example, if we want, here is a data visualization on map for the landslide in India, and here you could easily identify that this area is much more prone to landslide. Similarly, here these areas are very prone to landslide, and similarly, outskirts of these area are prone to landslide. So viewing data directly imposed onto a map can help you discover important patterns, outliers, and trends, which could help you to identify patterns, trends, and etc. So it could also be an impactful way of conveying your information to the other people. Once you are in research, if you want to show your research to other people, like, it is better to show on to the graph data visualization, and if it includes uh, geographical data, it would make much more sense to show it onto the map. So in order to plot data onto map, you need to find the position information that ties to the location, and typically in position information is provided into the streets. For example, in which street it lies, or it would contain geographical coordinates, latitude and longitude, or the name of the countries or cities. So now I have lot of libraries that could help to uh, convert your data directly onto the map. Now let's see which library would help us to convert this into the map. Now we are going to look at what are the libraries that we are going to use in this lecture. So first we are going to use tidy geocoder. We are also going to use at ggmap. Then we are going to use mapview, then chloroether, then sf libraries. Mostly we are going to play with mapview, and once in so so here are the following libraries that we are going to look onto. So the first one we are going to look at is tidy geocoder to convert your um, data directly onto the geo coordinate information, which will be much more clear in few minutes that we are going to use onto. Then we are going to use ggmap. We are going to use mapview. Then we are going to use chloroether, and then we are going to use sf. Basically, these are the 5 popular libraries used for map, and generally there are a lot of mapping libraries, but these are the 5 that you are going to use most. So now let us see how you could use this. So now let us see use tidy geocoder. So what is tidy geocoder? Basically, what it does reverse geocoding query. So what you could do is, basically, you could provide them your address, like where you live. For example, you live in Mumbai, India, and it will reverse geocode and provide you the latitude, longitude of that area. So now let me open my R console, and here I have opened my R console. Now let us see how you could use tidy geocoder for reverse geocoding. So basically, you provide the street area and you will get in response as a the location. So first we will clear our console. Control L, we will remove all the variables. So first what we need to do is we call location as a vector, and in this we could need to provide the address. The first thing we will provide is the country, and then next thing we need to provide a city. For example, we could provide the city. So it's a column, and we create the values for it. So we'll add values for countries, for example India, and then city Delhi, and we could see what the geolocation is for that location. So now we need to create a address for this which will contain the values for this for above statement. So concatenate, C is for concatenate, if you remember it concatenates the value. So for India and then city we are going to have Delhi, and then what we need to do is we need to create a data frame. So to create a data frame, we remember the method data dot frame, and then we just need to provide the rows name and columns name. So it will create the data frame for us. So we could say location and address. So let us see if it's correct, and if we open it, we could see that the country is India and city is Delhi. So it is correct. Now what we need to do is basically we need to add the do the reverse geocoding. So basically get the geolocation for this. So basically for this we know that we need to import our library uh, that is tidy geocoder, and in tidy geocoder, and in this there is a method known as geocode that will get or do or reverse geocoding. So we'll call first we will add this value directly to our data frame, and we'll call tidy geocoder, and in this we call geocode. We provide our table that is data frame, address is our address, then in the city we don't need to add, but the method we need to add, and this method would be our OSM, and what it basically fetching all the data related to the address that we have provided, and let us see it have completed. It is on 100%, and here if we open our data updated data, we get the latitude and longitude. Now, and if you are wondering what does method OSM is, basically it needs to get location from any service provider, and we are using OpenStreetMap for our service provider. Basically if you go to Google, and here if you search for OpenStreetMap, and here you could get, this is the free wiki world map, and it contains all the geolocation of the country and state. So it is basically saying, hey, give me the geolocation of this area that the city and state we have provided. And you could define more, you could add your real location and get your geocoding. So this might be a task for you. So what we need to do is, now we need to do we need to do a dot density plot basically for our Houston data set. And before that, let us see what is dot density plot and which is the Houston address is. Now let us see what is dot density plot is. Basically in dot density plot, what we do is we basically have dots to represent the concentration, and basically in dot density map, areas with many dots represents the high concentration of values for the chosen field, and fewer dots indicates the lower concentration. The higher the dot, higher the concentration, the lower the lower the concentration. And here you could see we have higher concentration here. Here we have also higher concentration. We also have higher concentration in this area, also in this area. So general rule is, the higher the concentration, the higher the value is for that area, particular area, and the lower the value, the lower the concentration for particular area. Now what data we are going to use? We are going to use ggmap data, In this, we are going to use the crime data set. Basically, it contains the housing crime data set from January 2010 to August 2010. So for this, let us see how, let us import this data set in R. For this, what will I will do is basically clear my script, will remove our console, I will remove the environment variables, and now what I will do is I will first import the data. So to first import the data, I will call data, and here I need to call the crime data set, which is inside the package ggmap, and let's just see that what the data set contains. So if we run it, it's saying it's running. Let us see if it's available or not. So we got our data set. It contains geographical location too. So we have block, premise, offense, street type, suffix, month, date, location. So it's good for our geoplotting. So what we are going to do is we are going to plot this. So first, what we could do is we could first import our library to plot this. So first we are going to use the ggmap library. And what is ggmap library? It is used to plot the data set directly onto the map. And let us see its documentation first. So basically here's the documentation, and you could see it's from the CRAN project, Comprehensive R Archive Network, and it provides the raster map tiles, basically vector tiles that contains the data details uh, of the location that where it is from. So basically it's used for mapping services. You need to use either Google Maps, which is paid, Stadia Maps you need to register and then get it. OpenStreetMap is used you don't require any API, so required any key for API key. So we are going to use OpenStreetMap for this. And here you could see that for Stadia Maps, if you are going to use the get the location from the Stadia Maps, it needs require API key, and similarly for Google Maps. So basically OpenStreetMap does it for free, so we are going to use that. Now let us open our console, and what we are going to do is first we need to import our favorite library, that is ggmap. And what we need to do is we need to filter the data based on the homicides. So we are going to plot it only for the crime that is done for the, let's say, for the offense murder. And to do this, what we need to do is we will call our first library ggmap, and we will create our homicide variable, and in this we will filter it. And before that we need to import our library for to do this, that is dplyr, which contains the filter package. And then in this we will provide crime, and we'll say offense is equal to murder, and then we'll run it. We get the crime, and let us see what the data set contains. So in this, all the data set for homicide, it contains the offense murder. Now what we need to do is we need to plot it. To plot it, we need to have a library that is known as map view, that will plot this onto the map. And let us see what is map library. So for this, to plot in our data frame into interactive map, we need a map view library. That what it does, it creates interactive visualization of spatial data with or without background maps. So this library we are going to use to map our data set, and we are going to use also SF. So SF stands for simple feature for R. Basically what we need it for, currently our data set is in data frame. So if you look onto our data sets, it is in type of a data frame, and this is not accepted by the map view library. as parameter, so it needs to be converted into simple features. And which what it does, it's a way of encoding data into a spatial vector data, that it what we are going to use it for. So now let us import our library first for this library, and then we are going to use map view. Then we are going to use library such as SF, and then what we are going to do is my map, and then from SF we are going to call a method st as SF. Here you could convert foreign object to an SF object. Why we need it? Because to convert our homicide data into SF object. So what we will gonna do is we call homicide. Then we are going to say coordinates, and in this, what we are going to do is we are going to provide our coordinate, which is a vector of lat and longitude, basically longitude and uh, yeah, and latitude. Then coordinates is of latitude. Then we need to provide coordination reference system, which is basically the standard way of notation of the spatial data set. Basically, you don't need to worry about, there is only general method to the represent the coordination space. And if you search for in the internet for CRS 4326, it's basically a general way of representing the data set for the globe. So what does CRS means? Use latitude and longitude to specify a location on the surface of Earth. And what we need to do is we will call map view, and here we will call my map, and here is a typo, and then we call map view map, and then let us see our map. So viewer, and here we get our data set for the house. Then that these plot you could see here are the density plot representing the value. You could see here the density in this area is way bigger. Let's see, here you could see 129.65, and basically it's only for the data set contains the location for Houston data set. That's why it is only for Houston. And you could see these all dot plot is for criminal crime rate, and you could see in the Houston middle part the most of the crime scenario is in there. Basically in this street also, in village, we could say that most of the uh, criminal activity is there, which is a type of a murder, and it's on the main street. Now we have seen the plot. Now it's time how you could use other method, how you could beautify this plot. Now let us see what parameters does my map accept. So my map needs to get the data in the SF format, and what other parameter we could do. So color, what is basically is for basically the outline color of this dot, and we could say let us keep it as black only. And now what we could do is for color dot region, we could set our color, let us say red, and it should be of type string. And then we need to provide the transparency level, which is called by alpha dot regions, and then we could add it to be 0.7. We could also change the type of map, and let us keep the type of map to be type of like OpenStreet. And to do this is we call map dot types, and here we call the or map OpenStreet map, and as it needs to be in the camel case. Let us save it, let us run. Colors matched by multiple match argument. So let us see here. This needs to be color instead of colors, and once we run it, we get our data set to be used by. It's the type of map is OpenStreetMap, and here our data set is represented in OpenStreetMap, and we have better visualization than previous one. Here our transparency level is 0.7. Either we could reduce it to be 0.5 just for better view. Yeah, now it's much more better for data visualization, and here we could see most of this crime rate are inside of Houston main capital. Basically, this area is whole Houston, and the outskirts also have much more crime rate, and you could deduce many much more stats from this graph. So now we have looked onto the how you could plot the dot plots. Now let us see how you could plot a chloropeth. Now it's time to look at the chloropeth maps. Basically, in dot density plot, we looked at how you could plot numerical values using dots. Chloropeth maps use polygons, basically an area, and use shading color to define the numerical values of that area. Now let's look what is chloroplet maps definition is. Basically, chloroplet maps use color or shading color to define the predefined areas to indicate the values of numerical values in that area. Basically, the higher the shading is, the more the value is. And here's the graph for a life expectancy, and which we're going to create in few minutes. Basically, here you could see we used the blue color to indicate the numerical values into the area. Basically, here you could see that the Canada have higher blue shade, and the value for that blue shade is higher, like basically 79.4 to 82.6, which is a range of life expectancy in that area, average life expectancy rate. Similarly, we have for USA, then we have for other country as well, and for black, which we don't have. Now, there are numerical ways that you could create a chloroplet maps, but one of the easiest way and industry standard is to use chloroplether package, and it is created by Aaron Lamonston, and we are going to use it to create our chloroplether map. And what do we do if we want to create a lot of customization? So in the end, we are going to use SF and ggplot2 library to customize those vector files and shape files that we get the data from. Once we call this packages, what it does, it calls a Google API or open source map, and basically it asks for uh, uh, ask the API to give them the data of that particular area, which is a vector tile that contains the information of the road, all the area geocoordination location, and we don't need to dive into what is vector file vector data for the maps. Basically, it contains all the logic for the creating the map tile or raster tiles, which is basically a map, and to customize it, we are going to use SF and ggplot2 libraries in the end. Now, let us start by doing the data by country challenge, and let us see what data we are going to use. So, for our data set, we are going to use Gapminder data, and already we have come across this data according making lot of plots on it. So, basically, we are going to use this data set to evaluate the life expectancy for the year 2007. So now let's open your R studio to code this out. Here I have opened my R studio. What I'm going to do is clear my console, clear all environment variables, and next what we need to do is, once we have clear our console, I will be importing the library that we need to use. First, we are going to use chloro ether, and it contains a function that is chloro country underscore chloro ether. Basically, I want to explain about this function, and once we press F1, it imports the documentation for that function, and basically it requires df, that is a data frame, and it should contains a region and a column name value, and uh, one of the other thing is in the region and all the country must be in smaller case, and it should be in standard naming. So for United States, US, it should be United States. For the Korea, it should be South Korea, and North Korea, it should be divided into. Similarly, for China, it shouldn't be Republic of China. It should be Republic of China (PRC). It should be China. So what we need to do is in our gap-minded data, it's not like that. So when we code out, we will look for that change. So first, we will need to import our data, that is gapminder. So we will import the data that is gapminder, which is inside package gapminder, and once I save it, run it, uh, I got my data gapminder, and here you could see there's 1704 observation. We are not going to do for this all year. Basically, we are going to do it for year 2007. So we need to use dplyr package. So for this, we will import our dplyr package. Why we need to do import dplyr package? Basically for data manipulation. And now let's create a variable plot data, which is a new variable which contains gap-minded data for the year. Let's get the year to be for the year which is 2007. So now let's see what does gapminder plot data contains. So basically it's saying can't okay, so basically we need to also have a one comma that I missed. In the square brackets we need to have one comma. If we missed, let's say we don't know how to, the compiler is giving error, that is logical subscript. So basically once we need to get the data manipulation, we need to add the comma. And plot data basically contains 142 observation, and here you could see some changes needs to be done based on Hong Kong. It should be changed to China, or it should be China. And let us see what changes we could do. Yeah, similarly for Korea Democratic Republic, we need to make it handle those changes as well. We need to make it for North Korea or South Korea. So let us code this out, plot data. And one more thing we need to do is we need to have the value to be in the lower case. So what we are going to say that plot data, and in this we just call a function that is known as toLower, and we get the data for our country. Now the country will be in smaller case, and now this needs to be saved in the region file, because we are creating a data frame that have a region and a column. So for region, we need to add this column region, then similarly for plot data, and we need to create a value and then in this we will add the uh, values for the life expectancy. So we you need to get the life expectancy, and let me check what's the column name for life expectancy. So life exp, and basically, yeah, it says that so basically it says life expectancy uninitialized column, and basically we had a typo here and we got our life expectancy saved for the plot data values. And now we need to handle this case for United States, Slovakia, Korea, Congress of Republic. So I have already coded this out. You could see this. Basically, I will go through this at what I have done. And what I have done here is basically taken those code that is not in standard format and converted into the standard format. For example, United States should be in form of a United States of America. Congress, Democratic Republic should be named as Democratic Republic of Congress. Similarly, for Yemen, Slovakia Republic, it should be Slovakia. Serbia, it should be Republic of Serbia. And once we are done, we could hit enter, and now our plot data frame is ready. It contains or plot data contains a region and a value that we need to plot. And basically you could see that it requires a region value to call this function, that is country chloropeth to map. Now once we have ready this, we will just give the we'll give this function country chloropeth, and then we just pass the plot data, and let us save it and run it, and we get our maps. Here we have some warning message that your data frame contains this some countries you could see that have been missed. The following were missed because some data were missed because their data was no data was available. For example, for China, for Guyana, Luxembourg, Laos, Kazakhstan, because and they have been plotted black because their data wasn't available. Here we have plotted out, and in the starting of the lecture we have already seen that it is now we include with app maps we plot based on the shading or a polygon area, and in dot density plot we use dot density to indicate the numerical values. Here we are using shading color based on blue to denote the value levels. So here we could see the Canada uh, have more life expectancy. Australia also have more life expectancy, and it's for year 2007, and now it might be changed. So what we could do one thing more is we could add a title and subtitle to it, and we could change our color too basically. And for doing this we could pass num colors and a value 0, a divergent scale used for value from, let us open the documentation itself to get the what value does it include. So the value number using, so if we call num colors, the num color of used to use on the map, 0 uses a divergent scale useful for visualizing negative and positive numbers. A value 1 uses a continuous scale usually useful for visualizing outliners and quantiles value. So we are using have to use any value between 2 to 9 basically for or quantitative value which we have, that is expectancy, is a quantitative value. So we could use 2 to 9. Let us use 9. And what we could do is, let us see how our map is. Now let us see. Here we have no changes right now. Let us see. Let us run 2. We have now we have outliners only till 2, basically 71 to 39.6 to 71.8. Let's say what if we do the outliners for 6, and we have 6 outliners, basically 3 for this and 3 for above, and rest for 9. Similarly we could do for 9. And um, what we could do, one more thing is to change the color of this, basically. And to do this we could use call a function scale fill brewer. Basically it will, we need to provide color padding to it, and there is a standard padding color code, that is YL or O or D. Basically this is the standard color code, and I have taken it this standard color from online, and I'm just looking into it. And here it provides standard color palette, but it's not showing. So the issue was that we need to call a parameter in scale fill brewer, that is palette, and in this palette we need to provide our color code. So basically previously we were not providing that method. That's why our code was breaking. Basically color coding was not applied, but we need to provide a color code in the palette member, not a generalized way. So y, and then the color code is L, capital O, R, capital R, T, then it will run. And now we could provide a title to it, labs, and the title life expectancy for the year 2007. Now let us run. We get life expectancy. You could add a subtitle to it. You could add also caption to this plot, and you could make this plot much more descriptive. So now in our previous plot, we looked at the data by country. So basically we have the data set and we represented as a polygon area, and which is a choropleth heat maps, but we have a data which contains a data frame of a country, and we use a function that is choropleth at country function, which does all the handling for or data visualization. Now what to do if we have data by state? So for this, choropleth each bracket provide the similar kind of function. We need to call state choropleth each function, and in those we need to provide similar to country choropleth each function. In this we need to provide a region and a value. So we need to provide those things. So to plot this, we just need to provide that requires the data frame. So we need to provide them the region and the value that we need to map. And this needs to be in lowercase. Also, this needs to be in the standard format. That is, it should not be in short forms. It should be in their long forms, how they are mentioned. So country should be in their standard name. The state should be in their standard name. So for this, we are going to use df pop state, and it contains population of estimate for US states in 2010. So what we are going to do is, let us create a new file. Let us save it by the name state by choropleth. And then what we are going to do is, first we are going to clear our console, Control L. Then going to remove all the environment variables, and then what we are going to do is, we are going to first import our packages. So for this, first we need choropleth eth, and we also need or library chloropeth maps that contains the map. So let us see what are the data that it contains. So df state, uh, and if this we need to call pop, uh, sorry, df pop state, the that contains the data set the this is inside the chloropeth ether package. And if we look at onto it, we get 51 observation, which basically contains the region and their population. So what do we need to do for this? So basically, in this we don't have to handle the edge cases. That is, that if there is they basically already in lower case, so we didn't need to handle that condition. So we could basically call state chloropeth at, and then we could just provide our data set df pop state, and then we could say let us map this first and then see. So we get a shade, and it basically contains 9 outliers, 6 outliers, 3, 6, and then the basic one. So let us, we have 6 outliers. So let us see if we add outliers for only for 3, and this is how it looks for outlier 3, but 6 is good. So we are going to keep it as it is. And now let us fix our color. So we are going to call scale fill, as previously we called brewer in our for our state, sorry, country chloropeth, we called this same thing. And then in palette, if you remember, we need to provide the color code, that is YLOORR capital R and D basically contains, and it's saying that it doesn't find able to file scale fill brewer. So let us see, is it and we import our ggplot2 library, which is inside contains the function for scale fill brewer, and we get our population heat map, you could say that. And mostly the population lies in the outliers of the water body. So here you could see Texas, California, Florida, uh, New York, Michigan. These all state contains most of the population, where the water is much more easily available rather than the inside of it. Previously, we looked at how you could use chloropeth map package to create a chloropeth map. Now, this is always not true. You want to have more control over your plot or your map plot. So you could use ggplot2 packages, but to use it with ggplot2, you need to use sf package, and sf package requires a shapefile. Basically, a shapefile is a data format that contains vector features such as point, lines, and polygons that is used to draw geographic boundaries of the map. Basically, it contains the information that how does the map look like. And for this, we are going to use this we are going to use this data set, that is United Census Bureau. It provides shape files, and we could use a 2.2 MB file. Basically, it's enough for us to do the data visualization. But if you need more data set, you could get those by adding more data to your data set. So what you need to do is just download this file. I will provide this link to the video description, so you could download the link. Now once you have downloaded it, now let us open our RStudio. Now once you have downloaded that folder, you need to change your directory. And to change your directory, you need to come to the files and where you have downloaded. So I have downloaded in files, and here's my US downloaded data. And here's a code that I have taken from online. What it basically does is it takes the shape zip file and extract it, and there from inside it there is folder that is this folder CB2023 QS state, which contains a shape file and extract it. And here we have all the shape files. Basically, it all contains the shape file, also needs these other files because it contains all the other data. So once we run it, we get all the data. Now what we will do is we will use ggplot to map this. So we will call ggplot2, and then we will call ggplot, and then we have the data, that is US map. Let's say US map. Then we need to say that it's a SF plot, that is simple plot files that we are going to use. So we have shape files, so it is going to use SF plot to plot it. And then we need a theme, you could say a minimal theme, and let's see what we get. So we get our plot. Let us see if we have a better theme, but it's okay. Let's see if we could say classic theme, if it's, yeah. But here we have got the plot, and basically you could also add title to it. And here how you could, this is how you could plot a using ggplot, SF plot, and based on your plot, your SF other plot would be shown. With this, in our next lecture, I will see you with the time series plot. With this, thank you everyone.